Hi children, good evening one and all. In today's class, we will learn most important concept in our chemistry, that is chemical reactions and equations. What is a chemical reaction? How a chemical reaction is going to be formed, and how we can that reaction, how we can change it into an equation. What does an equation tells, and what are the basics, basic foundations to in writing the chemical reaction, how to balance a chemical reaction. These all the things we will, what are the chemical formula of different substances, okay, different chemicals, different compounds, okay, we will discuss one by one everything in detail. Okay, come on. First of all, see what is a chemical reaction. A chemical reaction happens when substance changes and new substances are going to be formed. Then a chemical reaction is going to be takes place. The substance should not be itself. The molecules which are present in a substance should not be as it is. They should convert into a new molecule. They should convert into a new substance totally. Then that is called as a chemical reaction. So we have already studied different examples in our previous class of these chemical substances. Okay. We have studied lot of examples. You just once see that previous class and then come back to this class. Types of chemical reaction. We have different kinds of chemical reactions. We will discuss one by one. The first one is combination reaction. The word itself indicates combining, combination. Two or more substances joined together to form a new substance. At least minimum two substances should be there. They should combine. There may be more than two substances. They should combine and becomes a new substance. Then such kind of reaction we call it as combination reaction. I'll give a real life example. In order to prepare tea, what mothers do, they will do that, she will take one bowl and she will add water. In that milk, tea powder, sugar, okay. If even to get, so these are the basic things in order to prepare tea. So if you want extra, you can prepare some flavors also, like ginger, whatsoever. All should be heated, all should be mixed to form a new substance called tea. In the new substance, that tea doesn't have a complete characteristic of sugar. It doesn't have a complete characteristic of water. It doesn't have a complete characteristic of milk. It doesn't have a complete characteristic of what the essence that we have poured in the tea, in preparing the tea. So totally new substance has been formed. This new substance will not have any of the characteristic of the old one. Such thing we call it as combination reaction. Is it clear now? So the example is H2, that is hydrogen react with oxygen. Hydrogen, H2 is a molecule, remember that. H2, if you write 2 below, it is said to be called as molecule. Okay, there is a lot of difference between H2 and 2H, right? H2 and 2H. See now, H2 and 2H. 2H means two hydrogen atoms. One more thing children, few atoms we already studied. See, look at into our past videos, you will definitely get it. Hydrogen does not exist as single atom. There are few atoms, they will exist single, especially inert gases. Helium, neon, krypton, xenon, radon, these are all come under neon gases. They are more stable atoms. They will be existed in as single atom. There are other atoms, they will existed as two two hydrogen atoms combine together to form H2, hydrogen molecule. Two or more atoms combine together to form a molecule. We have studied in the past class, right? You just recollect everything and then come back to this class. Then only you can learn the things. Remember that. So hydrogen atom react with hydrogen molecule react with oxygen molecule to form water molecule, right? So to form water molecule. See here two molecules, one hydrogen molecule and one more is oxygen molecule. They combine together to form a single molecule of water, H2O. That is called as combination reaction. What is that? Combination reaction, right? So in combination, small parts come together to form something new, something big, like as that of we have discussed the tea example, preparation of tea example. So second one we go for decomposition reaction. It is also called as chemical decomposition. Combination reaction is also called as chemical combination, right? Chemical combination, and the second one is combination reaction. One substance break down into two or more simpler substance. This is exactly opposite to that of combination. In case of combination, two or more single atoms combine together to form a new substance. Okay, their combining takes place. Here it is exactly opposite. That is, water molecules, by making some effort on that, by applying some sort of energy to that, especially we use what is known as electrical energy there to split into hydrogen and oxygen. This is what we call it as electrolysis process. In future we will learn this. Okay, electrolysis. With the help of electrolysis we can divide water molecule into hydrogen and oxygen, right? We can, that can be separated, right? So water is divided into there a single compound that is splitting into different molecules. It is getting divided. So this is exactly opposite to combination reaction. And in combination, in decomposition, one thing breaks into smaller parts. Both the reactions are important in our daily life. See, think of one example of each combination and decomposition from your daily life. If you say that combination making water from hydrogen and oxygen, decomposition water break into hydrogen and oxygen. If you take hydrogen molecule and oxygen molecule, if you combine them, you will get water. Or if you split water molecule by any means, especially like electrolysis, or there are different several methods, by any means if you split it, it just convert into oxygen and hydrogen. Splitting we call it as decomposition, and combining we call it as combination. Remember that, children. Next, some more type, displacement reaction. This is another type of chemical reaction. In this reaction, more active element takes place of less active element. There is reactivity series. In future we will learn, right? So reactivity series. There are less reactive elements, especially gold, silver. These are less reactive elements. Okay, potassium, sodium. These are more reactive elements. More reactive elements will replace the less reactive element in an equation, in a compound, and they will occupy that place. So that is called displacement. For example, copper sulfate. Copper sulfate generally blue in color. When it react with iron, iron react with copper sulfate. Generally copper sulfate is less reactive when compared to iron. One thing you remember, that copper sulfate react with iron here because iron is more reactive. But copper won't react with iron sulfate. Remember that. Because copper is less reactive, it cannot replace iron. But iron can replace copper. So when it reacts with copper sulfate, it replaces copper and forms iron sulfate, and copper gets separated. So it displaced, iron has been displaced copper place, Iron occupied the copper place and copper has been left there. Okay, so this is what we call it as displacement reaction. When an acid react with base, okay, this is the other thing. So this is what we call it as displacement reaction. That is the first one. What happens here? More reactive element displaces the less reactive element. In those things, which is more reactive? Iron is more reactive. In future further classes we will definitely know. There is no need to worry. Just you know the example now itself. In future classes, which is more reactive, which is less reactive, we will learn everything, right, in detail. Okay, so this is the thing, iron sulfate and copper deposited on iron. Copper will deposit, copper will stay on iron there. And next one is, next type of reaction is double displacement. See here, single displacement. Okay, next in the next concept we go for double displacement. Example, the ions we know, there is nothing to worry. What is an ion? What is a compound? Okay, everything we learn. There is no need to worry. Alright, the ions of the two compounds exchange takes place to form new compounds. Right? See here, silver nitrate, which is colorless actually, it react with sodium chloride, that is salt solution. It will form what is known as silver chloride. Silver nitrate react with sodium chloride. Silver replaces sodium. Sodium replaces silver actually here. So that sodium is more reactive when compared to silver. Sodium will hold the place of silver. Then silver will hold the place of sodium. So both the things is they are happening. So silver chloride will be formed and sodium nitrate will be formed. So silver chloride is a white precipitate. Precipitate is one which will stay below at the bottom, which will stay at the bottom, we call it as precipitate. Alright, and sodium nitrate solution is going to be formed. So silver nitrate formula is AgNO3. Ag is the symbol of silver. Nitrate means NO3. Next, sodium chloride NaCl to form AgCl and NaNO3. Actually in AgNO3, Ag silver is positive and NO3 is negative. NaCl, Na is positive and Cl is negative. Here this positive react with combined with this negative, that is Cl. So AgCl, and the remaining positive and negative they will form one more compound, that is NaNO3. So two placements have been changing here. That is why we call it as double displacement. Okay, next the third one is neutralization reaction. Next one is neutralization reaction. So what is that? What is neutralization? What is the meaning of it? When an acid react with base to form salt and water. Acid react with base to form salt and water. Okay, so here the example is not given, nothing to worry. We will take one of the example, HCl, hydrochloric acid. This is an acid. This react with base, NaOH. It react with base. Actually, H plus and Cl minus is going to be formed. They combine together HCl compound. Na plus positive and OH minus, they both combine together to form a base. Here double displacement reaction takes place here also. So what happens here? Hydrogen positive will join what is known as OH. It will join OH. It will combine with oxygen to form what is known as H2O molecule, that is water, and Na combined with Cl, so that is NaCl. So that is salt. Salt and water are going to be formed. So in any of the compound, in any of the reaction, when acid react with base to form salt and water, this reaction we call it as neutralization reaction. What is that? Neutralization reaction. So displacement, double displacement, neutralization. In displacement, one element takes place the other element. In double displacement, ions exchange to make new compounds. Right? In neutralization, acid react with base to form salt and water. They are going to be formed. See. So changes around us, we have discussed several changes. These already we have completed that. It is physical changes and chemical changes. These are the changes where only size, shape or state is going to be changed. No new substance is formed. Examples are ice melts, water boiling, cutting of paper. These are all come under physical changes. We have studied vast regarding that, so that I am just moving fastly. So these are the substances where new substances are going to formed. That is burning of a candle, we will get smoke and moisture, okay, and rusting of iron, new substance is formed, iron oxide, cooking of food. These are all come under chemical changes. So changes caused by heat. When we heat some materials, they expand, they become bigger. When they cool down, they contract. Let us see how changes occur. A metal ring and a metal ball, before heating and after heating. Try passing the metal ball through the ring. Metal ball, try to pass through the ring, it will go through easily. Now heat the metal ball, try passing the hot ball through the ring. What will happen? The cold ball pass through the ring, the hot ball does not pass through the ring. After cooling, it again passes, because hot ball, it has expanded so that it doesn't pass through the ring easily. So that is the reason, because its size has been increased. Okay, what happens when we heat the metal object? It expands and becomes bigger. When it cools down, it contracts and becomes smaller. So hot ball does not fit through the ring, and cool ball will fit through the ring, because hot ball generally expands. Heat makes the things to expand. When heated, the objects can change the size. When cooled, the objects return back to the original size. So this is a temporary change and can be reversed. This change is called as temporary change. So rail tracks will expand on heating, jar lid will expand on heating, okay, hot air balloon and bridge gap between the bridge will be expanded through heating. These are all the examples of expansion through heating. Next one, expansion of liquids on heating. Till now we have discussed expansion of solids. So when we heat a liquid, its particles moves faster and spread out. Generally the solid particles are very close to each other. In liquid, the particles will be somewhat far away from each other, little bit far away from each other. That is why liquids will flow. Okay, this makes the liquid to expand while heating. So in order to do, let us have one activity. What we need? Plastic bottle with cap, straw we needed, we should insert the straw, colored water, pan and hot water. What we are going to do? Make a small hole in the bottle cap. For bottle cap, you just make a small hole. Fill the bottle with colored water. You fill the bottle with colored water. Insert a straw through the hole and seal it tightly. The straw should be kept and the remaining gap should be closed tightly. Place the bottle in a pan of hot water for few minutes. You take hot water in a bowl or pan, okay, in that you place this bottle. What happens before heating and after heating? After heating, what happens? Water level is going to be raised. Water level was very less. After heating, water level has been raised. Heating causes the liquid to expand. So liquid rise up in straw. In straw, the liquid is going to be raised up. Because of heating, it got some energy so that the molecules will try to expand. Likewise, we can do the example of, this is an example of expansion of liquid. The level of the colored water in the straw goes up. It looks like fountain of water. Okay. So what can we conclude? Heating causes the liquid to expand. Heat will cause a liquid to expand, so more liquid rises in straw. In straw, the more liquid is going to be rise while heating, when we heat that. See, when we heat the matter, it changes its state. Okay, till now we have discussed about expansion. Now it changes its state. These changes are reversible. For example, fusion. Fusion is also called as melting. What is fusion? Conversion from solid to liquid on heating. Okay, when solid is heated, it melts and changes into liquid. For example, ice. When we heat ice, it converts into water. So this is called fusion. Okay, fusion. And next one is evaporation. When we heat the liquid, it just converts into gas or vapor. Okay, it turns into gas. So water boils and turns into steam. Generally, at what temperature the ice get converted into liquid? At 0 degrees centigrade temperature, the ice get converted into liquid. Okay, generally if the ice was around minus 10 degrees, you think so, minus 10 degrees centigrade. Okay, if you heat it up to 0 degrees centigrade, the ice will be in the ice state itself. It won't convert into water. When once it comes to ice state, okay, at 0 degrees centigrade, once it comes into 0 degrees centigrade, the ice start converting into liquid. After completion of total ice getting converted into liquid, the liquid will also be in 0 degrees centigrade. After that, it will start It will start increasing temperature. Until total ice getting converted into liquid, the liquid will be in 0 degrees centigrade itself. That point we call it as 0 degrees centigrade. The temperature point we call it as melting point. Okay, and the heat required we call it as latent heat of fusion. It is called latent heat of fusion. In further classes we will still know very well. Okay, see next, in the same fashion, liquid convert into vapor up to 100 degrees centigrade. Generally at room temperature the liquid will be around 25 degrees or like that, maybe 20 to 30 degrees, that depends upon the area. If it is cool, it will be very less. If it is polar region, it will be around maybe 0 ice it will be. Okay, so when we heat the liquid, it just converted from 20 to 30, 40, 50, 60, 70, 80 up to 100 degrees centigrade. The water will be, liquid will be in liquid state itself. When once it gets the temperature of 100 degrees centigrade, after that its temperature doesn't rises. It won't become 101. Okay, it just start converting that liquid into vapor. That point we call it as boiling point. That point is called boiling point. The boiling point for water is 100 degrees centigrade and melting point. So this point we call it as where the water totally getting converted into 0 degrees and the converted water will also be in 0 degrees centigrade until the ice gets melt. Okay, that temperature we call it as melting point. Okay, and that process we call it as melting, and this process we call it as boiling. Okay, even condensation. What is condensation? If we cool down the vapor, it just convert into liquid, convert back into water. That is called condensation. Okay, so these are all the reversible changes. This can happen again and again. We can move from one state to another state and we can get back. Heating gives energy to the particles. Particles moves faster and spread out. Different materials changes at different temperature. Okay, water will change at one temperature and kerosene will change at one temperature. That depends upon the temperature, right? So can we think of the other example where the changes happen? Burning kettle, boiling kettle, drying changes, drying of cloths, cloud and rain, and water droplets on a cold glass. These are all come under other examples of change of state. Next, change in state of matter by changing pressure. If you change the pressure, then we can change the shape of the solid, volume of the liquid and gases. And it has little effect on gas. It has more effect on liquid, that is pressure. There is little effect on gas. See, effect on solids. Fluffy solids like sponge, bread, they get pressed but come back to their original shape after once you release the pressure. Ductile solid can be shaped as we want. Okay, so hard substances, when we apply large amount of pressure, we can change that shape. There are brittle solids like glass piece or like that, even mud. Okay, so they come under what is known as these solids will be brittle, means they will break down. So these are the things. So next, effect of liquids, effect on liquids. Pressure has very little effect on liquids. If you apply pressure, there is almost no change takes place in case of liquids. Effects on gases, it increases the pressure much. Okay, more pressure, and it decreases the pressure when we expand, right? Even see, if you are, in order to understand this, so in the gas which is present inside a matchbox, okay, that can be fit into a big room. I mean, the gas which is spreaded in big room, if you compress it, we can fit it into a small matchbox. Okay, so that much of change we can observe in case of gases. Okay, so real life example, when we pump air into a cycle tube, air gets compressed and takes less space. That is why tube becomes hard. This is a change in gaseous state called pressure. That is, tube becomes hard. Actually, without air the tube will be soft, and with air the tube becomes hard. Okay, so this is regarding pressure. Okay children, thank you. We meet in the next class. Right, I think you understand the concept. From here you are going to get much concept. Okay, don't forget to subscribe. Daily you should view, and daily at least you watch one episode completely and learn the things. Okay, bye children, we will meet in the next class.